Hello students, in the last class we have discussed the concept of order statistics. In this class we will learn the elementary formulas of order statistics. The first one is the minimum order statistics is always denoted by x suffix bracket 1. Maximum order statistics is always denoted by x suffix bracket small n. Range is always has the formula maximum value minus minimum value, and median has the formula for order statistics. Remember, in general, the median of the given data can be found by the formula in lower classes n plus 1 by 2 if n is odd. If n is even, n by 2 plus 1 whole by 2 is the median value if n is even. Likewise, here for order statistics case, here if n is odd, the median value is x n plus 1 by 2. If n is even, x n by 2 plus x n by 2 plus 1 whole by 2 is the median value. Now, the first quartile is denoted by q1, that is the value at 25 percentile. Third quartile is denoted by q3, that is the value at 75 percentile. Okay. Now, the interquartile range, that is q3 minus q1. Now, we will enter the important concept, that is PDF and CDF of order statistics here. We know PDF means probability density function is always denoted by small f of x. Here suffix capital X denote random variable x. The CDF is always denoted by capital F of x of the random variable capital X here. CDF means cumulative distributive function. We know the formula for PDF in terms of CDF is f of x is equal to derivative of capital F of x, where capital F of x is the formula probability of capital X less than or equal to small x. These are the formulas already learned in earlier classes. Now, how cumulative distributive function for the order statistics? Suppose x1, x2 and so on, xn are the IID RVS. Here, what is IID RVS? Here, first I indicate independent, second I indicate identical. DRVS means distributive random variables. What is identical, independent, distributive random variables? Here independent means given random variables x1, x2 and so on xn. Suppose the occurrence of x1 is not influenced by the occurrence of x2, x3 and so on xn, like x2, x3 and so on xn also. Here identical means the CDF and PDF of the given random variables are same. The CDF is always denoted by capital F of x. For random variable x1, it is denoted by capital F suffix x1. And the PDF is small f x1 of x. Means all CDFs and all PDFs are same. That is the meaning of identical. Okay. Now remember here In order statistics case, x suffix bracket 1 is the first order statistics. We know that x suffix bracket k is the kth order statistics, and x suffix small n is the nth order statistics. X suffix bracket 1 is the also known as minimum, and x suffix bracket small n is the maximum value also. Now we will check the CDF of all of the above here. Suppose now we are going to find CDF of the maximum value order statistics, that is x suffix small n. We have the formula for CDF of a random variable x is capital F of x is equal to probability of x less than or equal to small x. But for order statistics x suffix bracket n case, we have the formula, the above formula can be converted like this. Capital F suffix x suffix bracket small n of x is equal to probability of x suffix bracket small n less than or equal to x. Remember here, maximum value of x1, x2 and so on xn, here minimum value of x1, x2 and so on x1. What is x suffix bracket n from the above? That is the maximum value of x1, x2 and so on xn less than or equal to small x. So maximum value of x1, x2 and so on xn less than or equal to small x means every element of this bracket value is always less than or equal to small x. That is probability of x1 less than or equal to small x, x2 less than or equal to small x and so on xn less than or equal to small x. Remember here x1, x2 and so on xn are independent. That's why this can be written like this: p of x1 less than or equal to small x, p of x2 less than or equal to small x and so on, p of xn less than or equal to small x. Here x1, x2 and so on xn are random variables. We have the formula here is x1, x2, xn are identical independent identical distributive random variable, that is IIDRVS. We have the formula probability of x comma y is equals to p of x into p of y. This can be written if x comma y are independent. Okay. So remember here the first value p of x1 less than or equal to small x, p of x2 less than or equal to small x and so on, p of xn less than or equal to small x can be written. Here check this formula here, p of x less than or equal to small x is fx of small x. Here capital X, in place of capital X after p notation we have x1. That's why these are denoted by like this: capital F suffix x1 of x and so on like this. So all are identical here because here the random variables are IIDRVS. That's why all are equal to one CDF, that is f suffix of x. This is all the product of n terms. So f suffix small x whole power n. This is CDF. This CDF is nth order statistics. So nth order statistics CDF is this is. Now we will find what is the PDF of nth order statistics. We have the formula PDF of random variable x in above, but for nth order statistics we have the formula fn of x is equal to derivative of capital Fn of small x by using this formula. Since now fn of small x is equal to derivative of what is capital Fn of small x, this is the value fx of x whole power n. So derivative, applying derivative here, n into fx x power n minus 1 derivative of fx of x by using the formula derivative of x power n. What is derivative of x power n? N into x power n minus 1 into derivative of x. So fn of x is equals to n into capital fx of x whole power n minus 1 whole power n minus 1. This is also whole power n minus 1. So derivative of capital F of x is always denoted by small fx of small x. Okay, since derivative of capital F of x like this. So derivative of capital F of x is equal to small f of x. So this is the nth order statistics PDF formula. In the next class, we will learn first order and kth order statistics formulas also.